Hi, welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. Let's continue right where we dropped off in the previous session. Maybe this should be even different. Well, let's revisit later. Let's first test if... let's go to our main function. Here, main. Here, main. Let's put a stack string. And let's put 16 str. It's undefined. Oh. Maybe. Okay, so WSTR. So let's see, str dot assign. So 16 characters minus 1, so 15 characters. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. That's 16. That's one too many. Actually, no. 16. The 16 doesn't include the null terminator. Right. So this string here should fit in there without reallocation. And the same here, this one. Okay, let's see. Good. So str assign, and the buffer is now inline storage. Yeah, no, heap storage. Oof. It is on the heap. Now that is unexpected. What about this one? This one is also on the heap. Why? 16. So str dot capacity int cap size t cap cap 2 w cap cap 2 cap 2. All right. So it's str. Oh, cap is 14. Let's see, why is this 14? Has lookup table is true. Still true. Why is this still true? Didn't we we tried so hard to get rid of this. Didn't work. Has store code point size is true. Is UTF-8 string is true. Huh. Yeah, okay. Maybe we need to do it differently. is UTF here, UTF-8 char. So how about we do if def this, then small, let's do small UTF-8 char type. If def small UTF char type, then we do this. And then we go to our common types. And then let's say we create a struct dummy or UTF-8 char. Can it be unnamed? No. Char C. Okay, so this essentially should now disable that thing, maybe. Oh. Buffer front. Yeah, well, we make it 8-byte type. 8-byte or void type we cannot do. UTF-8 operator. Maybe it should just be char. Static assert. The character type must be non-array, trivial standard layout type. Okay, that doesn't work either. So how about we put uint. We can do uint 8t. Yeah. Which is unsigned char. Yeah. Let's see. It's still 14. I have no idea what this does. Conjunction. Is convertible. Okay, I don't know about this one. How about here we use std is same v. Oof. Okay, same v does not work. Std is same. Is same value. Somehow it doesn't work. Oh, type name. Type name. Oh no, it's not a type name. A Unicode char is required. Whoa. So this thing wants us to force use UTF-8. Okay, what happens if we remove this here? Okay, so now the cap is 15, yeah. And we assign, yeah. And now it is inline storage, yeah. No, it is still on the heap. Oof. Okay. Jesus Christ. First, second, last. $16. Well, this looks expensive here. Yeah, so these strings actually do more than I expected them to do because of this UTF-8 crap. They have a lot of overheads, computational. We don't need this. We only want a ASCII or multi-byte string and not UTF-8 or UTF-16. I don't know what's up with that. Formal improvements. Formal improvement. What is formal? Okay. Discussions. Small ideas. Oops. Allow small string to use for ASCII, for plain ASCII and multibyte without the UTF-8 code logic. To be used for ASCII and multibyte without the UTF-8 logic. From what I have seen, when stepping through codes, is quite a bit computational overhead for the UTF things. I think this is not necessary when dealing. I suspect this is not necessary when dealing with pure ASCII and multibyte strings. It would be great to differentiate, to instantiate different types. From what I've seen when stepping through code is quite a bit computational overhead for the UTF strings. I suspect this is not necessary when dealing with pure ASCII multibyte strings. Perhaps make small basic string ASCII is UTF-8. Char UTF-8 wchar t multibytes char 16t UTF-16. Okay, that would be great if that could be done. Yeah. Yeah. Okay. Okay. Okay, so what I would like to do now is first we need to revert all the edits we made to this file. Okay, and also to this file. All right, so let's default again. Then we go to util. No, comment types. Comment type here. Good. So in our ImGUI app. So I think we need to make some actual tests now. First, so I would like to simplify this stuff and no longer pass a buff. So let's comment this guy out. Yeah. Buff. And this as well, buff. Good, then move this. All right, then this, and this. Okay, and then we go this and this. Good. Then we remove. Yeah. Okay, and then here we put a stack string. Well, realistically, how much do we need there? Can do stack string and probably that's probably no longer than, let's see, 11 times 3. This is 33. Yeah, okay, let's put the 64 for safety. Let's put buff. Let's just call it bytes. No, let's call it str. There we go. Good. Okay, and this one here we can Yeah, this one should probably be stack string str. And I think we can just assign it straight away. No. Okay. Then we do it differently. str assign. That works. Strip in place. There we go. There we go. All right. Okay, and then here you can also not pass this one and here. Good. Okay, then we can also remove this buff here and this one. Good. So I would like to write it, but now I'm a bit suspicious of the small string because of this UTF-8 stuff. I wonder how. I hope it's not now slower than our previous implementation with std string. So what I would say we do now is we create an actual measurement of this stuff. Do we have pics installed? Yes, we do. No? Yes. Okay, so we should probably compile with release, which I hope will run. We haven't run it. We haven't run it in release once yet. Only ever in debug. Yeah. Yeah, it would be great if if we could have an ASCII string or multi-byte string. There's not much activity here on this repository. Okay, it compiled. Let's see if it runs. Oh, we should probably remove this. Okay, so let's make this a bit larger. Right. Okay, so let's see. By the way, that went, hold on, imgui. So imgui is pretty big now, imgui, but it opened pretty fast, didn't it? Let me see, yeah. It was a bit faster, but in debug it loads slower with the ini, with that ini file. Okay, let's see if it compares in principle. Yeah. Okay, that was pretty fast. Then let's close this. Let's open the pix capture, local machine. So we want to attach. Hold on, unassemblize. Debugging. GUI. Yeah. Okay. Data, yeah. Okay. We probably want to launch it without the debugger. So you go solution, release. So oof. Probably unassemblize .but. Then we do solution unassemblize.exe minus GUI minus thyme.pdb game.dot, right? It's like this, let's say. Yeah, okay. Good. Then let's start a capture. So unassemblize, refresh. Yeah, okay, so we want a timing capture with 8K CPU samples, call stacks, doesn't matter, this window, virtual alert, no, and output directory, let's create a new folder here, pics select. Okay, so actually, yeah, let's put it here for now. Okay, good. So yeah, so we started timing capture. No target process has been selected. Why not? Attach. Okay. And then, yeah, we start the capture. Oh shit. Okay, we need to restart this program as administrator. Usual bullshit. There we go. Unassemblize, attach. All right, so pics, okay. All right, let's go. Start capture, and it runs. Okay, let's do our actions, compare, and click here and all, let it run. And let's just scroll to the end. I don't know if that made sense. Okay, let's do a new capture. I think we did too many things there. Stop. Let's do it again. Let's delete this capture. All right. Good. So we started. Select this, compare. That was fast. Click on the first, Control A, and done. Okay. And then we stop the capture. There we go. Okay. Good. So zoom in. Somehow it's really laggy. Why? Manage symbols. Okay, why do we... Okay, is this like a too old version? Oh. I'm missing some buttons here. I have the impression that this is an old version. Pics for Windows. Downloads. Wait, what version do we have? Pix 2108. Yeah, it's a bit on the older side, I guess. Okay, let's download the last main version here. There we go. Okay, it takes a moment. Okay, let's close this one then. Don't save. Okay. All right. Oh. Why is this so slow? Bah. So slow. All right, good. And that probably launched it again without administrator rights. Pix. What? Run as admin. All right. Good. I don't know why it says ready on here. Okay, so yeah, this looks a little bit more modern. Pix. Jesus. Okay, so we want to have CPU samples, 8K resolution, the memory. We don't really care. Kernel. Yeah, I think this is fine. So this attach. We need to restart this. So we're looking at this. And we are looking at unassemblize, and yeah, that's it. Okay, good. Then let's start the capture. There we go, and compare, and click the first, Control A, let it run, done, and stop. Good. Good, so let's see. Timeline. Good, so we have some threads here. Now the question is, where's our main thread actually? I don't know. Let's see. Threads with cause takes place. Aha, here. Okay, so this looks to be our main thread here. Okay, so there's quite some work here already. Yeah. Selectable is a lot, 2.7 milliseconds. It's probably the functions and the bundles list. Well, two functions lists, yeah, on both sides. But it's still quite expensive. But yeah, okay, that's quite a lot. Good. So let's try to find the here. So we should give these threads names. It's hard to see. C++ set thread name. Threads. Set thread name. What the fuck is that? Thread local name equals name plus fetch add 1. What? How is this working? I don't understand. Thread name, return name. Huh? What? It's just to print it out. Okay, I see. That's useless. Okay, so this seems to be all Windows specific. Is there no pthread set name? Pthread set name. Okay, so that's like a Unix thing. Yeah. Okay, so it seems to be no portable way, at least not a, okay, it's not a big deal. So we have here function disassemble. Let's see what is expensive in there. Oof. Can we? Which thread is this? 20896. This one. Boof. Okay. Sample functions. Okay, there's some cost with basic string. That's for symbols, adding symbols. We have also small vector. So this is okay. Disassemble. Okay, so the biggest cost is the format. Site is format or format. Huh. Okay. Decode. Okay, we need to create a second capture to compare this against. So let's close this. Let's stash this. Let's compile. And then we create a new capture. All right. Oh, no, we don't want to do this. We want to run it from here. There we go. Okay, so let's start a new session here. So this session is now with the former, without the stack string stuff, as we had it before. Okay, so start capture. There we go. Okay, select that, compare, select the first, Control A, let it run, and done, and stop. There we go. Good. Then we grab. Well, first we need to find the functions. Yeah. Okay. Let's put them. Let's put this to the top. There we go. Good. So then here we also start grabbing it here, and then we go build comparison records. Build comparison record. Okay, so it looks like the UI is a little bit glitching here. This one is not a valid section, right? It's hard to see. Okay, so we make a selection. Jesus Christ. Selection from here to up to here. There we go. Okay, so this is the first, and the second is also from there to there. Okay, so we can now look at it. Okay, so can we actually show it as milliseconds? Not sure. Okay, so okay, so here the disassemble costs 18,400, and here 19,700. So this is the old one. Timing 2 is the old. So here seems to be more expensive. Let's see. So Zydus format instruction. Format instruction. Into. Decode instruction. Okay, so this calls into our functions here. Let's see. Okay, so this is a new one, and we see here samples are 1,130, 600, 400, around about. And here we have significantly more. Yeah, so this can we. So this is 4802, and this is 35. Yeah, so it would be nice to see it in milliseconds. Like, so this is 1.144. 1.080. Yeah, so here it took, well, it's only a couple milliseconds faster now by the looks of it. Where's the bulk of the cost? Oh boy. No format. Get symbol. So get symbol is pretty hefty. Yeah. And here we have basic string assign. This must be also from the symbol stuff. Basic string assign. Yeah, it's about the same. So I assume this one is for this symbol, adding to symbol, add pseudo symbol. Maybe. Get symbol. Basic string assign. Small vector. Okay, I still don't see like where our savings are now. I don't see it. I mean, this here is cheaper, yes. This view is so crappy. Comparison. So we can compare it with this one here. I've never used this view. How does this work? Huh. Wow. I don't know how this helps. Okay, so we have, can we maybe, so this is sample function here, it's 18443. And here, this is sample, it's 19728, yeah. So it is cheaper according to this. Yeah, I would like to see like where exactly this cost is. So if you look in here, Okay, here. Yeah, so it does a format, and that probably also allocates to string, yeah. To string char 500. Huh. So if we compare that with this one, operand mem, operand mem, oh. Okay. So here Zion string append format. So that takes 101. And here we had 180 with FMT format. And then append format. So we essentially killed this one here. Right. Okay, so this is much faster. That's good. Well, much faster. It's relatively faster, yeah. Okay. Now I'm interested. What is this here? Oh, what is that? Update info. Ah. How long is this? 16 milliseconds. Update info. Okay. Yeah. This one has quite a bit of cost here. Yeah. To string. So here's the allocation. Yeah, it needs to allocate a lot of stuff here. Okay. Okay, he gets more and more expensive. Okay, how about after we have, yeah, how about we take a fixed amount of seconds after we kicked off the disassemble. So, okay, so here we kicked off the disassemble. Let's start from here and take 5 seconds. Exactly. There we go. Okay, so 5 seconds, and we do the same here. Once we started here. There we go. 5 seconds. There we go. Oh, what happened? 5 seconds. Okay. So 5, 8, 5, 7. So now the question is, can we see any of our costs here? So yeah. We need to select the correct lane. Where are we? Huh? I don't understand where I go back to. How do I go back to selecting threads? Where is it? I don't understand. Oh. I just want to select the threads. This threads. But somehow I can't get there. Okay, I don't understand why I cannot select the. Where is it? Where? It was here before, no? The thread selection. Where's the thread? Where is it? That's not it. I don't get it. It's probably all together, actually. Okay, so ImGUI is the most expensive stuff here. Create new window. Get default table height. Get max table height. Comparison manager named function entry. Is disassembled, also is matched. Yeah, is matched function. Function lists. Selectable. Okay, this one we can probably optimize with the clipper, right? Yeah. Okay, I'm not seeing any string allocation positions here. I think the string allocations, they're just so small. Can we search for maybe basic string here? Basic string. Okay, here we have some std basic string. Disassemble. Yeah. Basic string. Small. Okay, so we have a basic string here that takes considerable, 1000, and then we have some others that the small string, and that one is almost no position. This one is almost no position. What I would like to see is how expensive is... right. How expensive stack string. Right. We're looking for function print ASM assembler. This one, right? Yeah. Let's let's put this here. Print ASM instruction here. There we go. Okay, so that is pretty cheap here. Let's see, how expensive is it here? It's cheaper here. So we actually made it more expensive now, didn't we? Yeah. So it looks like using the buff as we passed it before was actually cheaper. Not that it makes much of a difference here, but this was actually cheaper. Look at that. Well, let's see. Oh, we cannot look inside here. Okay, so we made it more expensive. Yeah. Let's see some other samples where we used stick string. Manage stashes. So let's check the create section string. How this compared. Okay, it doesn't show up here. And it doesn't show up here. Okay. Then let's check. Let's see if create time string is there. Create time string. Oh, that is there. Okay, so here. Okay, so this shows as 3. And this one shows as 1. Okay, so it looks like we made it this one cheaper. Well, the sample size is kind of low here, right? Okay, but it's probably the allocation that, yeah. Okay, let's look at some other sample. Let's look at this one here. So this one shows with 7 here and 19 here. Yeah. Okay, so it looks like that creating the stack string in the function actually has some overhead compared to our previous strategy of just passing the std string as our buffer. Yeah. Yeah. Interesting. Okay, but these are so small numbers here. Yeah. Okay, any other things to look at? Let's compare this one here. So this one is this one is 608. And this one is twice as much. Yeah. Okay, so we certainly made good savings in the Zydis function. These are up to twice as fast in the formatter because we got rid of the string allocation and yeah, like formatting extra step and then copying over. So yeah, we saved on that. So that's good. Good. Then let's see, what else did we have? So this looks good to me. This probably is good, but yeah, it's so small. Let's compare this one here, the progress overlay. File manager, no. Let's compare this one here, if it makes sense. Compare. Where do we compare? Hello? Here. So this one is 2 here. It's pretty fast actually. And it's 3 here. Well, it's noise at this point. I suspect that the stack string, because of the UTF, has some computational overhead. Whereas SCD string mostly has its data bounds, probably, because it goes into the heap. I don't know. Where are we? Here. Okay, so we didn't do actually much, right? We fixed this guy here. And we fixed this guy. And yeah, so yeah, so this is it's too bad that we cannot look in here. So the biggest cost in there is small basic string operator equal strip in place. If we compare this one, print asm instruction. This one is so much faster. That's amazing. Okay, that is truly amazing. Huh. That's truly amazing. You know, we don't really see much gains with these stack strings. So I'm inclined to not use them for the time being. Because here actually it got more expensive by putting the stack string into the function, and what we had before was faster. So I'm inclined to, we keep the optimization in function. We use stack buffer where it makes sense, but we don't use it much yet. Yeah, I'm kind of surprised that it doesn't bring that much gains, or actually makes things slower. Okay, but I'm happy with the function Zeitus optimization, so that's good. At least something. Good. I would say I will take a break now. I will clean up tomorrow, revert most of the stack string stuff. I think we can actually completely remove it. We can keep our helper functions maybe. Yeah. And then, yeah, we keep on using std string for now. Yeah. We need to make some proper observation for stack string. Yeah, I think the problem with the stack string is this UTF-8 thingy. It makes it more complicated than it should be. Like, from what I've seen in debugging, there's additional overhead. And that's probably not healthy. Yeah. Good. Yeah, okay, but we know what to do now. That's good. Then, yeah, I think afterwards, once we have concluded this, you can do the clipper optimizations. So we need to add clipper to the functions list, the bundles list, and I think we also need to add it to this list here, basically this window here, this. So what happens right now is all these things here are being rendered, which makes it extremely slow. So I think we can see it here. if we look at function here. Here, so we just zoom in here. So this is one frame. Yeah, and it takes 17 milliseconds, 18 milliseconds. And named function entry, and there's a lot of begin childs here. Yeah. So this is super expensive. Yeah. Okay, so we will try to use a clipper for this. And then comparison. What else do we have here? Comparison manager, named function entry. Named function. Aha, here, functions lists. Yeah, so this one takes 8 milliseconds on its own. That's pretty expensive. Yeah. So that's just functions list. What about bundles list? Here, bundles. Huh? Bundles, settings, bundles, settings. Oh, okay, it's just one sample. Yeah, okay, but in the functions list, there's not much inside, so that's why it's not showing up. Yeah. Okay, it's just a functions list because we have 20,000 function lists in there. So yeah, that understandably takes 8 milliseconds. Okay, good. But the biggest position by far are the individual name function entries. Yeah. So we need to get this under control. Good. Yeah, let's save these captures here. Save. Can we just like can we just take this name here? Okay. Good. Then yeah, good. Then we revert the stack string stuff. We keep using std string for our buffer. Except for the Zydis here. Hold on. Where is it? Function CPP. So somewhere here is a stack string, right? Stack. No. Oh. Where is it? Oh boy. I thought it was here somewhere. Here, instruction buffer. There we go. Oh, it's a std string here. Oh. Oh, hold on. So let's do stash pop. There we go. So here's stack string. Instruction buffer. There we go. So what I think we should do here is we just put a stack string, like a literal stack string. So a char array. And then we pass that down. Or we put a, hold on. Instruction buffer. Yeah, I would say we do a char buffer, and we do 1024. Yeah, and then we create a std string view buffer, instruction buffer, and this one takes our buffer. Okay. And then we take this guy and we pass this here, std string view, instruction buffer, and then here we pass buffer, instruction buffer. Okay. And then stack string. No. Here. Instruction buffer. Oops. Std stack. No, std string view. There we go. But hold on, string view is const, isn't it? I think this doesn't work because data, can you? Yeah. I think a string view is const. Yeah, const. So data returns const pointer. Ah, okay. So string view can only be used for const context. Huh. Right. Then we would need to pass. Then we need to do it differently. Then we do instruction buffer. It's on the stack. And we do instruction buffer, and then we do size of instruction buffer, which is 1024. There we go. And so custom instruction buffer, let's do char. We could also pass a span, no? Yeah. Span char instruction buffer. There we go. Span char instruction buffer, and then data size. Yeah. Okay, and then we do yeah, then we just pass instruction buffer. Okay, this should work. Maybe. Yeah. Buffer, instruction buffer. Okay. Good. Let's close this one here. Yeah, this compiles. Okay, good. Then this is settled. Then the rest, let's do it next session. I think we're done here, 2 hours. Yeah. Good. Yeah, I thought that we would get more gains out of stack string, but it wasn't so expensive to begin with. But we got big gains out of this thing here, where we removed the string allocation here and the FMT formats, and just pass it straight to the Zion string formatter. That makes it much faster. Yeah. Good. Then I hope you enjoyed. I wish you a great day or night. Until next time. Goodbye.